Here, did you calculate Bathos oil before moving on? Yes, I did, but you don't have to. It's just out of, I don't know, I just do it every time just to make sure that everything is calculating okay, to see the properties, and mostly to make sure that I actually have an oil phase, right? For some reason, it's not showing here, for example, in the gas. Okay, something is not right. For example, in the gas, just to make sure that I have the right phases, right? But it's not necessary. It's not necessary to calculate that because once you add the saturator, in order for the saturator to work, the software will make sure that everything is calculated before the saturator runs. So you have two options. You can calculate it or you don't need to calculate it. The software will do it for you, especially if you're going to saturate. So that's an option. I have another question here. It says, how do I decide the entry options for the oil for a future project? When to pick, let's say, API 8, etc. So really is based on the, I don't have the best answer here, but it depends. It depends how your data was given. Were you given a distillation assay, or did they already give you the pseudo components? Because you don't have to go through all of these entries here if you already have another software or somebody has given you already your pseudo components and you simply enter them in here. So for the assay, well, it depends. I really cannot give you a good answer here. Sometimes they will tell you, I give you distillation column, but maybe in some other analysis they have used the ASTM D86, or in some cases you don't even have we don't even have the options here for some of the oil analysis. So then is where you use the pseudo component tab, because there are so many ways to create an oil analysis that we simply don't have them all covered in this tool. So it will depend on the laboratory data that they are giving you. But if you have any questions about how to enter this data, you can always give us a call and we can help you to define how to enter that specific oil analysis for your studies. There is another question here that says, does the oil analysis have a significant effect on scaling tendencies? And I would say it depends, because let's say that your oil analysis, like in this case, we have CO2 concentration, and sometimes when you have the CO2 concentration or you have H2S in your composition, or sometimes even water, you will have partitioning of components from, let's say, the oil to the brine to the oil. And if it's a CO2, if you're partitioning CO2 from the oil to the brine, then that CO2 is going to interfere with your alkalinity value, right? And that will also have consequences in your scaling tendencies. So another thing that you could do to answer, or we could do to answer that question, is what happens if, like, what if scenario. So we can always increase or remove entirely the CO2 concentration and see how the scaling risk changes by changing that oil composition. Let's say I say that the ones that play a significant role for the scaling risk would be CO2, H2S, and the water composition as part of the oil. Okay. We can always play with those numbers of CO2 taken here and see what happens, what could happen with the scaling risk. Okay, so I think those are the questions I have so far, and we can move on. Okay, so we have created these three analyses here. And now we want to add a saturator object to create the bathos reservoir. So we go to the Actions pane, and then we double click on it. In this action pane, in this saturator tool, now we are going to rename it bathos reservoir. Cool. Okay. Now, for this specific reservoir, the production rates for this bathos well were given in English units. Okay, so we're no longer working in metric units. The information was given in English units. So before we continue doing any calculation, so we need to set up the units of this bathos reservoir, okay? And so how do we do that? So we simply click on this bathos reservoir just to make sure that we have selected it, right? Just that is highlighted in blue. And the next step is we're going to go to the units manager, okay? So click on this units manager on the top in the toolbar, and it will open the units manager for this specific bathos reservoir. Make sure that it's specific for that icon, okay? By default, because at the very beginning of the class, we set the units for this for the saturator as scale metric, okay? So what we want now is English, scale English. So we're going to click on the scale metric and look for the option scale English. Okay. But really, this is not giving us a lot of information what is being changed. So if you want to find out or see more details about the units, we can click on the Customize button. And in here, you can see the units for the stream amounts. For example, for volume, now we are going to be talking about barrels per day. For mass, it will be pounds per day, okay? And for moles, it will be pound-mole per day. That's regarding anything related with mass and concentrations. For parameters, in here, temperatures now are in Fahrenheit, pressure in bar G. You can also see some of the energy properties are also changed to BTUs, etc. So these are going to be the changes. Make sure that you have Fahrenheit and bar G. Okay. And then let's click on OK to accept the changes of these units and click OK again. So now you immediately see temperature change to Fahrenheit and pressure to bar G. And once we have made these changes in the units, now we can start adding the production rates for the brine, the oil, and the gas. Okay, so let's go to type here, the first column, and select, let's add the brine. Okay, I'm going to add the brine. The brine that we are going to study is the Olympus brine. No, sorry, the bathos, the one that we just created, the bathos brine. Okay, and the flow of that bathos brine is 850 barrels per day. So you see here, barrels per day have already, the units have changed to barrel per day. Okay, so that is with the brine. The next fluid that we are going to add is the oil. So we select on type and then click on oil and select bathos oil. And the production, this is flowing at 2,200 standard barrels per day. So it's 2,200 standard barrels per day. And finally, since we also are going to have a gas in here, a gas phase, we're going to select the gas type, select the Bathos gas, look for Bathos gas, in this case, the last one. And we are going to specify that it's flowing at 300,000 standard cubic feet per day. So I didn't put the 1,000 there because it's a standard 1,000 cubic feet per day. Okay, so it's 300. Now, those are the flows. Okay, those are the rates. Now we need to define the conditions of this reservoir down here in this section. So this reservoir is at 200 Fahrenheit and 220 bar G. Those are the conditions. And I wish I could make this bigger. Yeah, I can. So 200 and 220, 200 Fahrenheit and 220 bar G. Okay, so this is nothing different that we have done, that we did in the past in the class on Monday. Okay, so the next step now is to go to solid, the solid tab. And in here, we are going to select the standard solids. Again, this means that if anything is super saturated here, we will allow the solids to precipitate, okay? And we are not saturating, in this case, we are not saturating this reservoir with any mineral, okay? We want to find out first what are the compositions of the brine composition, what's happening at reservoir conditions without saturating anything first. And notice as well that now you see here siderite. Okay, the siderite here. In the previous example, we did not have any iron concentration in the Olympus brine. We did not, the iron concentration was not reported. So the solid siderite was not even wasn't even part of this standard solid selection for scales. Okay, so because now we have iron in the sample, then siderite is one of the potential solids that could precipitate out. Okay, so let's go ahead and calculate this to find out what's happening at reservoir conditions. Okay. I will save after this. Let's save just to be safe. And now to analyze the results, we go to the report tab. Okay. We have already gone through these tables. The one that I'm interested here is the pre and post scaling tendencies. So let's scroll down to find this table. And we are looking for any values that are near one or more than one for the pre-scaling tendencies. So what do we have? We have siderite is 13% saturated. So it's basically subsaturated. Barite is also subsaturated, 40% here. And we have the calcite is 78% saturated. Everything else is undersaturated, is subsaturated. Nothing else is really closer to saturation except this calcite, which is 78%. So you could continue, you could say, okay, I'm happy with these results, or it could be reasonable, it would be reasonable to say, okay, I know this is a sandstone, and I know that I've got calcite cementation in the reservoir. Then perhaps it's a good starting point to saturate the brine with calcite. And we could do that. This will account for the maximum risk conditions. So as I showed before, we go back to the design tab if we want to saturate with calcite, okay? And we can basically tell the software that we want to saturate the reservoir with calcite. And that's what I'm going to do for this example to account for the maximum risk of scaling. So if we go back to the solid tab, then go to the mineral saturation section, and we are going to select calcite. Okay, so we select calcite and then click on the yellow cell, and the software knows that in order to saturate with this, to make this fluid saturated with calcite, we need to vary this inflow, calcium carbonate. So again, the software will be varying calcium and carbonate ions, and ideally it would be nice that we could just move the carbonate ions, but if we do that, then we don't conserve the electron neutrality of the solution. So that's why the software does it as a molecule. Okay, so once we instructed the software to saturate the fluid with this mineral, then we can go ahead and calculate. Oh, but even, sorry if you click on the calculate, let's also calculate the alkalinity. Click on this calculate alkalinity, because what we are going to do here is that we're changing the carbonate ion composition of the fluid, and I just want to make sure that we are not changing significantly the alkalinity of this fluid. So let's just click on the calculate button, and we will go to the report after the calculation is done. Are there any questions about this specific step, or any questions before this step? Okay. So I hope everything is clear so far. The calculation is done here, and we can go now to the report. Okay. So in this report tab, again, we have already, last class I spent significant amount of time going through these tables. So in here now you see, you know, that this delta means this is how much the software added of this calcium carbonate as an inflow in order to reach saturation. Okay, so it's 50.96 milligrams per liter. Okay, these are the conditions of the reservoir. This is the total mass. In here we see the pH at reservoir conditions. Down here we see the volumes. Okay, these are the volumes of the brine and the volumes of the oil. And I'm interested to see the brine composition. At this point, I want to see the brine composition. We are making changes to the solution, so I want to see how much we have changed the composition, the original composition that we entered in the bathos brine. So we'll see here that initially, let's look for calcium. Initially, in our bathos brine, or the brine analysis, the total amount of calcium that we entered was 850. Okay, so basically the amount of calcium has remained constant. It's basically no change here. It's like 0.4% change. Okay, now the other thing I am interested to know is the bicarbonate value, right? Because as we are adding or removing carbonate to the solution, my bicarbonate will be changing as well. So at these reservoir conditions, the concentration of bicarbonate is 568 milligrams per liter. Okay, so if we go and compare it to the bathos brine, so we go and check the bicarbonate value. So I am in bathos brine, in the report of bathos brine, and I check the bicarbonate value. So this initial value was 495 milligrams per liter. Okay, so By saturating with calcite, we have increased this bicarbonate value to 568 milligrams per liter. And this is an increase in concentration of around 14%. So based on these results, what would you say? You would say that the changes are small enough? Would you not saturate? Would you saturate? Or perhaps this is within the sampling or experimental uncertainty. Okay, so that would be, you could run two examples. You could run an example by not saturating and an example by saturating this fluid with a mineral. But for this example, I want to saturate to account for the maximum risk, and I will not make any changes. Now, additionally, I want you to scroll down. This is the brine composition. In the same brine composition, notice that since we have a gas phase and an oil phase, you can see that now this brine composition also has some pseudo components that have partitioned into the brine. Okay, and you can see also some methane has partitioned into this brine. You see that the methane here is about almost 500 milligrams per liter. Okay, and some of the pseudo components have made it into this brine, as well as the nitrogen. Okay, so we are seeing here some partitioning between the phases. Okay, now if you scroll down to the oil composition, okay, in here you'll see that initially in our oil, when we created the oil, we did not enter any amount of water. But the software is saying that when this fluid is saturated and at equilibrium, the composition of the water is 0.49 mole percent in this oil. Okay, so that means that some water mass has been transferred from the brine phase to the oil phase in this case. And you can also see some dissolved CO2 in the oil phase. In this case, it's 0.86 mole percent. And if you remember, in our oil analysis, we put a value of 1.1 in the oil composition. So we are seeing here a reduction of CO2 in the oil phase, and that could be due to the transfer of CO2 to the brine phase, to the liquid phase, right? So and you see, sure enough, you have some CO2 in the brine phase. So everything is being partitioned, transferred, and the software is calculating the composition of the brine, the oil, and the gas at reservoir. Well, in this case, no gas, because everything is in the oil phase. Let's see. Yes, everything in this phase properties is telling me that we have a brine and that we have a liquid composition, meaning that if we had a gas, everything is compressed and now is part of this liquid two-phase or organic phase. Any questions about what I just talked about? I hope I did not confuse anybody here. Okay, we can talk a little bit more about this. So in this phase properties table, so we have three columns, right? So we have the liquid one, is indicating the brine or my aqueous phase. I have the solids, and I also have the liquid two, which is the organic phase. Again, there is no gas column because this is implying that at reservoir pressure, all the gas is compressed into the oil phase. Okay, so for example, in here you can see that at standard conditions we have 850 barrels per day, right? But at the reservoir conditions, which is this value here, is 871 barrels per day. So the software is predicting a higher amount of brine at reservoir conditions, and this could indicate that some water is being transferred to the other phases along the production line, right? Because we are actually having more brines. So something is happening to the water. We are producing exactly 850, okay? Then we also have that for the organic phase at reservoir conditions, we have 2,400 barrels per day. And at standard conditions, the volume goes down to 2,323 barrels per day. So again, this difference could indicate that as the pressure is indicating that as the pressure decreases, some gas is escaping the oil phase, hence causing a reduction of the total volume, right? Going from 2,400 to 2,300. Okay. So any questions about this? I know it's a lot of information. But now that we are happy, or at least I'm happy with this saturation or with this bathos reservoir, now we can produce it. And that's the next step we're going to do.